if we want civilization to work, institutions have to work. And there's not an institution today in the world that isn't dependent on computers at some level, many on big levels, all manufacturing, everything else, right? Cyber is a part of every conflict now. And the power of what you can do with cyber exceeds all these fancy weapons that everybody talks about. Almost everything is now run by electronics of some sort. The way attacks happen, they just don't come out of blue. I mean, they penetrate, they stay, and one of the Raytheon's metrics for cyber was dwell time, which is how long malware has been in the system before I found it. And if you can block the first outbound communication from malware that it's ever tried to make, then you have a zero dwell time event, meaning somebody got in, but before they could phone home and say, hey, I'm here, what do you want me to do? They were blocked.
Ed, it's good to see you.
Good to see you.
Maybe just to start off, could you give us just a bit of an overview of your background and some of your career highlights?
Sure. I started my career as a software engineer at IBM, about 10 years, then got into the wonderful world of entrepreneurial startups in California. Did that for the bulk of my career and finished up with 10 years at Raytheon. So I have bookends with 2 large companies and lots of startups and exits along the way.
What was the company that actually got you into Raytheon? What was the actual technology?
It was a company called Trusted Computer Solutions, and we cooperated under a cooperative research agreement with NSA to build a secure version of Linux that we then used to build applications on that allowed the intelligence community to share information from one security level to another. Normally that's not done. Those networks are not allowed to be connected so that they're secure. But obviously after 9/11 happened, people got to realize that these agencies should share more. So a very specific kind of software that needs very specific functionality in the operating system was what Trusted Computer Solutions sold. And we actually partnered with Raytheon for a couple of Intel customers, and then they bought the company in 2010, and I stayed there for 10 years, longer than anybody guessed, and helped build the Raytheon Cyber Products business, which I ran. And then we sold that off to a joint venture that eventually got renamed Forcepoint. When Raytheon and United Technologies merged, that got sold off to private equity. Today it's something called EverFox, also owned by another private equity firm, and doing quite well.
So my understanding of Trusted Computer Solutions, TCS, was it was really a cross-domain. It was effectively allowing secure data to be securely shared between people and systems without significant overhead, having multiple devices on the desktop.
Right. Our most frequently used PowerPoint slide was a picture of a typical Intel analyst workspace, and there's like 8 workstations there. And there's a top secret one, and maybe another top secret one, and then a couple secrets, and a bunch of unclassed ones. And the point is that that takes a lot of power, takes a lot of energy. Each one of those boxes was tied physically to a different cable. And that's really the way the intelligence community was probably a short 20 years ago. And we were able to collapse that onto one workstation, which saves power and energy and everything else. Plus, you're allowed to move things back and forth. There's 2 types of cross-domain solutions. One's called access, one's called transfer. Access just means I can sit at one point and have fingers in multiple networks, but I can't move anything back and forth. I can just see. Transfer is a device that actually allows you to move information from one to another. And that we call them guards. Those guards are specifically attuned to the requirements of sharing classified information from one domain to another. Typically, the top secret is the high domain, secret is the low domain, and then unclassed is the other one.
And so this was back in the 90s, 2000s era?
This was, I started with the company in 2000, and we did the NSA Linux project in 2003 and 4. So it really started to take hold around 2005 and 6. And we had rapid growth during that time. Prior to that, there were some cross-domain solutions, but they were hardware dependent and very expensive and very cumbersome to implement. So as we know in security, you can spend a lot of money, but if it's too cumbersome for users to work with, then they don't typically use it. And cross-domain software sits at that apex of security and usability. And I always say that if we tweaked our software, 2 notches to the right to make it more secure, it would be so difficult to use, users would never use it. And if we tweaked it about 2 notches to the left to make it less secure and more user-friendly, the accreditors that are required to approve the use of these software tools, they would not approve it. So I've been in software my entire career, and this is the most complex, the most delicate balance between functionality, usability, and security that I've ever seen.
So is it fundamentally a question of data security? I mean, ultimately, this is a tool to enable data security with some amount of sharing, but hopefully only to the right people?
Right. It's to bring assurance to the sharing process so that when you do share, as we have to, instead of just using commercial standards to do it, you're using a different standard of security, a different standard of cybersecurity on that technology.
It's the reason I was asking about the time frame is I feel like over the last, call it 5 to 10 years, more on the commercial side, we've been seeing a shift towards centralization of data, largely to be able to envelop that in security controls. So rather than having data at the edge on laptops that can get, in theory stolen, but in reality left on trains, right, and just left lying around. Right. Centralizing that data now, centralizing that in the cloud, and develop that in security, and then selectively allow certain people with access. How have you seen the transition, having kind of started with it in the 2000s to where we are today? How is that, I guess, promulgated out from? It sounds like started kind of more on the federal side, and then gone out into the commercial sector.
Yeah, it's a good observation. There has been a desire to reduce the attack surface and centralize data in areas where we can control it. We've had conversations about, well, how do we get there? Why is security such a big deal? Well, if you think about it and go back to the 50s and 60s when computers were starting to get wide acceptance, we had 2 models. There was the mainframe model, which all the data, all the programs were in a raised floor, secure location. The only thing out there was dumb terminals. So you had control of your data. And we promptly went to client server, which put client servers all over the organization so that any respecting CIO can't say, I know where all my data is. And now we're trying to pull that back a little bit. On the other side, the PC side, we made a similar error. We started with PCs that were secure because they weren't connected to anything. But we connected them all to each other, and now we've got Pandora's box, right? So one of the elements of good data security strategy is to reduce your attack surface and get the data away from end devices, endpoint devices, and back into a centralized area where it can be secured. That makes the security a little bit easier to attack, but it still requires dexterity in terms of balancing security and the ability to share. And there was a great story during the Afghan conflict about an LA Times reporter that went into a Kabul market and bought a dozen or 2 memory sticks just to see what was on them. And sure enough, he found a memory stick that said, hey, our agent lives at this address. He gets $800 a month. He gets a $1,000 bonus if he brings us this, et cetera, et cetera. And, you don't know for sure, but most likely the culprit there was somebody needed to share information that was in a top secret network over to an operational secret network. So they copied it to a memory stick, pulled it out of one machine, stuck it in the other machine, and they thus shared information. Problem is that information's still on the stick, so falls out of your pocket, cleaning lady picks it up, who knows what happened, but that's how it happens. So these cross-domain solutions I mentioned, they share electronically and do not use physical media to do that. In fact, after that incident, you may remember the Pentagon outlawed memory sticks forever, or at least they tried to. The problem with the security networks in the intel and the defense communities is that, if there's no way to share it and people's lives are at stake, you're going to break rules to share information. And you can imagine a guy in a command center who says, look, I got the map right here in this system, but I can't send it to the guy. Well, damn it, download it to this and send it. So, we made great strides both in the amount of sharing and in securing the way we share. But yes, the consolidation of data is one step and a good one toward doing that. And today, what we used to call old dumb terminals are best described now as these thin clients that are where the data is not existing on your actual laptop, but it appears to you to be. That way, if the laptop gets stolen or something happens, you haven't lost your data.
How has that technology been impacted by the change in threat actor? And I'm thinking specifically, 20 years ago, the only people who had the resources really to go after sensitive data were nation states. Of course, now you have ransomware gangs that are making hundreds of millions of dollars because we're paying the ransoms.
All right.
Have the ways in which we're supposed to secure data, has that fundamentally changed, or is the concept still the same and we just need to implement it better?
Well, yes and yes. Some things have changed. Clearly, implementation is a big issue. The industry has produced hundreds and hundreds of security tools that are either poorly installed or not installed with an eye toward harmony between those tools. There are certain areas of cyber that have not matured very well. One of them is the user identification sector. I mean, we're still using passwords like we used 30 years ago, and we probably need to move beyond that into more sophisticated ways to identify who is actually at the endpoint. But I think there's a need to rethink, now that we understand better the importance of cybersecurity, how we identify people, where the data is, and set an architecture that encompasses both data at rest, data in motion, and the endpoint data to be intelligent about how those endpoints access the corporate data.
What was that period of time like during the process where you had pure defense contractors with a cyber portion that then became defense contractors, and cyber companies?
Yeah, so Raytheon had a pretty aggressive cyber acquisition process. The Raytheon business development team, which was a robust, skilled team, probably bought upwards of 25 cyber companies in a period of about 10 years. I joined about halfway into that process. And one of the things that we wanted to look at was which of these cyber companies actually had software products that people could install and use versus which ones were very proprietary, government-only, project-based kind of technologies. So we went through the portfolio and pulled out the companies that had, software products that we could sell. We put them under the umbrella of Raytheon Cyber Products, and that was the organization that I ran. And then we took those products not only to the government, which was our traditional customer, but also to commercial customers, and equipped them with insider threat tools and information sharing tools and boundary technologies that they had not necessarily used before. And that grew like leaps and bounds, and the company was so interested in getting into cyber that the strategy was to go acquire a large commercial entity and put these technologies together so you have immediate distribution through the large commercial entity and the core technology in Raytheon. Part of the mission also was to mine inside Raytheon for technologies that could be commercial products. So we took a couple of technologies that Raytheon, under their government contracting, would just give away free and packaged them up and made them software products that the company could actually sell to both commercial and the other. I was also fortunate to live through the Swanson to Kennedy transition, so I had weekly meetings with Swanson then Kennedy as they transitioned the CEO role between that.
It seems like there's a trend of technologies starting in government or being built for fairly specific government uses, and then transitioning those out into the commercial setting. If I think about cross-domain or VDI, kind of started with centralizing data, and then commercial companies now, like as you and I worked on together, are trying to rebuild or trying to achieve the same result. I'm curious, what has been the benefit of having both a federal customer base as well as a commercial base? Is that, in your experience, is that better? Is it more useful? Or is that, it's a different culture for sure, but has it been overall beneficial to have both of those when you're trying to build a company?
I think it's very beneficial to have both. I mean, cyber technology is unique in the sense that the use of cyber to secure data at a certain level is the same whether it's government or industry, right? But because of the requirements of government, classified networks and security, et cetera, there's more attention paid to the robustness of those security tools. And there's an entire part of the process called security accreditation that doesn't really apply so much in the commercial world, but that does apply in the government world. So your government business has a larger service tail on it because you've got to go through certification processes for every implementation you do, whereas that's not the case in commercial. I mean, you could argue that it shouldn't apply to commercial because it would slow things down, but it does make you engineer your products and watch your implementations to be sure there's a certain level of compliance and security. And it's not compliance to various rules, it's specific to the implementation. So the certification process and the government may say, look, you've got several products here, and that's fine. Those products are individually certified, but I'm going to certify the entire system as it's implemented in your location to make sure it's up to snuff. So that's an additional cost to the business, and it's a time drag on both government and the industry to get it done, but it probably results in a more robust security stance generally.
What was it like being inside a true defense contractor from the perspective of seeing cyber operations, or not necessarily seeing the operations per se, but how is cyber viewed as a tool of statecraft, as a tool of conflict? Would be very curious, kind of what your perspective was on that, just having been both on the Raytheon side and then sort of post that once you were at Forcepoint, which is kind of more commercially focused.
Yeah, I mean, cyber permeates everything that Raytheon did. I mean, every division of Raytheon, whether if they were in the business of equipping submarines or making missiles or whatever, all had a large cyber component in there. And the cyber component that was pure cyber, which I ran, crossed all those boundaries. I think Raytheon recognized that cyber is a part of every conflict now, and probably a large component and growing. The power of what you can do with cyber exceeds all these fancy weapons that everybody talks about, because almost everything is now run by electronics of some sort. So, and the guys that practice the cyber operations are somewhat dumbfounded every now and then, because the leadership will say, well, first we're going to go over here, and then we're going to go over here, and then we'll get to the middle. And they're like, why? We'll just go right to the middle and stop it. The importance of cyber in warfare is much more important, I think, than people think. They think that's a component, and it is a component of overall, but it's one of the effects that you can have on targets. You can have electronic effects, kinetic effects, and cyber effects. And I think Raytheon was early on embracing the concept of let's look at multiple effects and see what we can do with them.
How have you seen the evolution of the human element to cybersecurity over the last decade? And the context there is recently saw that the estimate of the number of vacant jobs in cybersecurity has increased. We're now at 4 million vacant jobs. How has that impacted the ability to do what is required, number one, but then also maybe taking kind of a more neutral perspective, what does that actually mean for the industry overall? Like, can we, despite these job numbers, can we do everything that we need to? Can we leverage technology to fill the gap? What's been your experience so far, and where is that trend going?
So automation's a wonderful thing, and there's not been enough of it in cyber. I think we're entering a phase where we can automate certain parts of cyber that we didn't automate before. It's the only way we're going to close that gap, because the gap's higher now than it was 3 years ago, and 3 years ago is higher than it was 4 years ago. So, we're going the wrong direction in terms of cyber. So, and that gets back to sort of a holistic approach and looking for how technologies can complement each other and use them, and how you can use one technology to solve, one set of problems, and then use another one to do something else. But there's a need for automation. Maybe AI can help with that to some degree, because in some sense AI is an automation tool to speed up processes. The cyber education is one way to address the problem, but the challenge with that is the technology is changing so fast that you have to define what kind of education you're actually giving someone. And if the education you're giving them is how to configure a firewall, although technically that's cyber education, it falls under that broad name, it's not the kind of skills that are needed today.
What's your perception? You mentioned AI. What's your perception or intuition around where we go from here over the next, say, 3 to 5 years? Is AI going to be a force multiplier for the good guys, for the bad guys, for both? Who's going to get it first? What are your thoughts?
Well, both. It accelerates everything. I think on the defensive side, AI can automate a lot of the activities that aren't necessarily considered advanced cyber and sexy stuff, but are the vulnerabilities a lot of people attack, right? I mean, one of the classic is print servers, right? Because people don't update print servers because it breaks printers, and when printers don't work, people get mad. So, surprisingly, or maybe not to some people, but print servers are an attack surface that is very well liked by the bad guys, because that's usually out of date, right? So, I mean, if you can automate the updating process and automate the process of keeping everything to a certain standard across your operating systems and all that, that's probably going to help a lot. It's also going to help the bad guys because they can go creative. I mean, the history of cyber has been a constant, one up to each other kind of thing. I mean, there's that what's the old saying about every day a gazelle wakes up knowing it's got to run faster than a tiger, and every day a tiger wakes up knowing it's got to run faster than the slowest gazelle or it'll starve. So it's not a bad description of the world of cyber.
In one of the other conversations, we were talking a little bit about the fragmentation in cybersecurity. Pick your statistic: 4,000 cyber companies out there, all vying for, all vying for the cell phone number of the CISO of a large bank. It seems
Right.
like. What's your sense right now on technology versus people? So I feel like some elements are, yes, you need the right software. We just touched on, is there enough people out there to actually do the work of configuring the firewall or deploying the VDI solution or what have you? But what's been your experience around the relationship between technology, people to actually solve a problem, and kind of where are we in the equilibrium? Do we have enough technology? Do we have the right technology? Do we have the right people to deploy that technology? If you were to if you were to try and fix one of those two problems, which one would you focus on?
Two reactions to that. One is the biggest need is for the correct strategic thinking about cyber before you start buying tools. As you pointed out, and the cyber industry, we fund a company, it builds a tool, they hire a sales force, they run out, knock on every CISO's door. You got to have this thing, and if he doesn't have something to protect that particular piece, he buys it and puts it in, and off you go, right? But what's most important is to start from the basis of how do you think about cyber, and how are you approaching it from a holistic point of view. And by that, I mean things like the healthcare analogy, right? I mean, if I said as a human being, I'm never going to get sick another day of my life, you wouldn't believe me, because that's not a credible statement. And yet a lot of cyber people kind of get to this point of, I'm going to be so secure that nobody can break in. And you can't think of it that way. You got to think of it much more like healthcare, that you're going to get sick. The other thing is that, 80%, despite all the, the times we've taken to tell people to look at the inside of the network, 80% of the cost is still going toward firewalls and perimeters and things like that, right? And if you look at a budget, probably a CISO should spend half his money on finding the intruders that are already in your network and the other half on the perimeter. Because if you're not compromised, then you don't exist, because everybody is. And if you look at all the big hacks that are the OPM hack years ago and those things, all those things had dwell times in the 200-300 day range, right? So, the way attacks happen, they just don't come out of blue. I mean, they penetrate, they stay, and one of the Raytheon's metrics for cyber was dwell time, which is how long malware has been in the system before I found it. And if you can block the first outbound communication from malware that it's ever tried to make, then you have a zero dwell time event, meaning somebody got in, but before they could phone home and say, hey, I'm here, what do you want me to do? They were blocked. Now put yourself on the side of the attacker in that scenario, right? You've sent out your thing to penetrate, but you never heard back, so you're not sure what happened. So maybe you do another one. This time you're a little bit more noisy and a perimeter technology catches you. Or eventually you just move on to the next target, which is going to be more vulnerable for you. So, I think the getting the thought about cyber down first, and that usually entails hiring some pretty experienced cyber folks that have lived through these processes and understand them. But just buying more tools and putting them in, you just get to a point where you've bought every tool you can see, and you still feel vulnerable, and you're not on top of it. So. Knowing what's in your network, looking for those behaviors like lateral movement that depict something odd going on, those are very needed skills, and we're still too focused on the moat and castle theory. It's just human nature to think about building a strong wall and keep those people out, but this is more like healthcare. You can't do that. You've got to be a good internist.
I mean, that matches what we're seeing. Our services, so the Pluralot Critical Services Group has been growing at a rate of 2x for the last, I think, 3 years. Exactly as you described, we had a situation last week where the critical services team, they were effectively threat hunting on behalf of the customer, and they found that communication. It was one device that signaled to a command and control center. Thankfully, the signal was blocked, but we identified it, and we were able to nullify or neutralize the threat before anything actually happened. Now, because nothing happened, that was the success. Of course, you can't necessarily put out a press release saying, "Guys, nothing happened. Mission accomplished. Nothing happened." But it had nothing to do with the software. I think that was the key item, and I think that's part of the confusion or the misconception is that cybersecurity is a software problem, whereas from our perspective, it's a people, process, technology problem. Yeah, you need the right software, absolutely, but unless you have the right people and the right processes to be able to put it in place. And to your point, bringing in the guys who have experience, guys and gals who have the experience, who have been there, done that, who have lessons learned potentially from not only other customers but also other industries. Going back to what we were talking about earlier around best practices inside government, inside DoD, being able to leverage those into commercial entities. It seems like that's at least for the foreseeable future, until AI upends everything. It seems like that's what we need to continue to do to accomplish our mission, which is to keep our customers safe and compliant.
Absolutely. I mean, it's like the old tennis analogy, right? I mean, I use the same tennis racket that the best guys do, but I don't play this well. So it's not the racket itself, it's how you play it. And it's the same thing with the cyber tools. I mean, it's not the tools themselves as much as how they're set up in a network and who's advising and who's watching over the right things. And that's a real big talent. I mean, it's hard to find that kind of talent. And I don't mean to in any way say that configuring firewalls isn't important, but so much of, I mean, you meet people at, industry things and, I'm in cyber. What do you do? I've just finished, configuring all my firewalls. And okay, that's an important piece, but, to really address this problem, you have to think about it strategically and in a sort of holistic way. And that's what's needed, I think, the most.
It's interesting your point about the perimeter. I mean, if I think about who are the largest cybersecurity companies publicly listed today, I think of Palo Alto Networks, Fortinet, Zscaler, all three of which arguably are mostly perimeter companies. They're doing other things now. Yeah, but it's an interesting observation. I'm really curious. The last I'd say 2 to 4 years, particularly from COVID onwards, really focused on ransomware as a threat, and it brought to the forefront what a financially motivated threat actor can do. It's not just about stealing data or encrypting data. It's also, hey, can I take down a factory? Maybe there is no sensitive IP in there, but if your factories don't work, that's worth a huge amount of money. And in fact, speaking to one of our customers earlier, CEO's number one fear is ransomware taking down their factory and being unable to produce. Right. So I think that ransomware financially motivated threat actors are at the forefront. But I'm super curious, again, based on your experience and your perspective, how should we think about cybersecurity as a tool of statecraft, as part of conflict? Where do you see that going, kind of next 3 to 5 years?
Well, the importance of cybersecurity can't be understated at this point. I mean, if we want civilization to work, institutions have to work. And there's not an institution today in the world that isn't dependent on computers at some level, many on big levels, all manufacturing, everything else, right? So when it comes to ransomware and the people that do that, it's clearly a multifaceted approach, right? I mean, detecting the kinds of activities that could lend them to give them capabilities to shut you down. And then when it does happen, how you do the remedies, how you do the negotiating, who you choose to do that for is critically important. I mean, there's ransomware cases where people have paid, 10% of what was originally asked, and then there's cases where they paid 50, 60, 70%, right? So clearly there's a wide diversity of talent in that arena, right? And there's a relatively small number of law firms that specialize in that arena. That's gonna need to be more robust as it goes forward. But there's a huge amount of technology that's needed, not only in the detection of that, but from a CEO or a board level perspective, and this was true of the Raytheon board and even private company boards, that's a very real concern, and it's something that the company needs to be addressing straightforward and, with a lot of their best thought, because it can bring you down. You can do anything. When I was at Raytheon, I was in charge of the defensive cyber. There was an offensive group as well, and I always tell people this story that if you're a software guy like I was, and we give them a piece of software to say, hey, see if this is secure or not, the best compliment you'll ever get is, this will take some time. It's like the old Frank Sinatra song, the difficult I can do right now, the impossible will take a little time.
Sure. Nothing's unhackable.
Right. So that's really true. But they tend to not go after the difficult ones because that'll take 2 or 3 months of work, whereas the other stuff they can do right away. And so that's, one level. Another way to say it is your typical company defenses may have like a 6-foot wall, and we try to think of more like a 20, 30-foot wall, which can you get over it? Sure, but it's a lot more difficult. And as long as there are 6-foot walls to conquer, you'll go do that.
So what's been your experience? How have things changed in how companies are valued from a cybersecurity perspective?
A huge change in the last 20 years. It used to be that if you had a cyber company and you had 80% commercial customers, 20% government, another guy had a cyber company with 80% government, 20% commercial, the first one would be valued at 10 or 15 times trailing revenues. The other guy would be valued at 1 or 2 times trailing revenues, because traditionally government contractors only do services, which is lower margin than products, right?
Thin margins, troublesome customers, they take long to pay. Why would you want that market?
Right, except what people figured out is government's not going away, and it's not getting any smaller. And it turns out that government needs cyber as much or maybe more than the commercial people, right? And the cyber services can be quite profitable as opposed to traditional government services, which are low-cost bidder oriented, right? Now that extends to not only the cyber companies that make the software and the services, beyond the defense contractors themselves, right? So, I mean, the company that we sold to Raytheon is a perfect example. I mean, it's now valued in the billions, and yet still it's almost 100% government customers, right? So it's been a big change, and that means that the companies that supply the government with technology, especially cyber technology, are having great strides forward in valuation as opposed to that in the past. That's a big change. We tried, before we sold to Raytheon, we tried selling products to commercial, had some limited success there. And that was our major reason to get the valuation of the company up. But once we got into Raytheon, we started selling to the government, and the Wall Street and the people who value companies began to realize that, hey, this is great, steady business. It's pretty much recession-proof. I mean, it doesn't matter what the economy's doing, the government's still got to defend itself from cyber attacks. And, by the way, defending itself from cyber attacks, on balance, isn't as costly as building new aircraft carriers and all the physical things we do. I mean, another good telling example of the twist of things in the last 20 years is, at some point, the Naval Academy gave up teaching the sextant because GPS, we don't need it anymore. We got the position of our ships now. But then some cyber folks said, by the way, what if all that stuff goes down? And people said, oops, maybe we better have a backup, right? So a sextant is about the most cyber-proof tool you can use because you need no electronics for it, right? And that's true with a lot of things now. So there's been a rebirth of those sort of off-the-grid technologies that we know will still work in light of any big cyber attacks.
So I can relate to the fact that to the uneducated observer, government services tend to be frowned upon, looked down upon, thin margins, et cetera. But it also sounds like some of the smart money. I mean, you're talking about all the private equity firms when you're talking about your career. Right. It sounds like the smart money is already figured out that, hey guys, actually, if we can buy something that people maybe are not as attracted to because we realize it's horrendously sticky, highly repeatable. To your point, it's going to grow because the government's going to grow regardless of what the economy is doing. Right. That actually sounds like an arbitrage opportunity.
Yep, absolutely. And I've seen it. I've seen private equity firms go on bouts of trying to buy lots of government contractors that have unique technologies, even if they're small and not that profitable, because you can just see the growth going. And it's much more steady growth. I mean, from a financial point of view, it's a better investment because you're not dependent on the cycles of commercial sales forces knocking on doors and trying to get things sold. I mean, the government's need to share information is not going away. The size of the government databases is not getting smaller. And so technologies that secure that and that allow that to be shared are going nowhere but up.
I think there's also a bifurcation happening in geopolitics right now. You've got effectively the West and the East. You've got not only the United States, which I think the U.S. government is maybe the largest buyer of IT services in the world, if I'm not mistaken. But then you've got a number of alliances. You've got the Five Eyes Alliance with U.S., Canada, Australia, New Zealand, and the U.K. And then you've got NATO, and there's friendly camaraderie, kind of at a cultural level, and that also presents, I think, commercial opportunities. If you do well in one government, presumably you can do well in another. And there's a bit of a closing of the ranks as well. I mean, we saw a desire to move away from Chinese networking equipment with Huawei. We saw a desire to move away from Russian antivirus with Kaspersky. And so what does that mean? Well, it actually means that if you're a pure play Western company with cyber capabilities, the field is being tilted in your direction in some respects.
Yeah, I think that's true. And I think that's also extending into the commercial multinational corporations now.
How so?
Well, so many of the corporations that are multinational now have citizens in countries that don't like each other, right? And so how they protect their IP, their valuable information becomes very challenging because it's not like they can say, well, only U.S. citizens are going to be able to access our network, which is what the government can say. They can't do that. They've got plants in China and places that they have employees, right? So, how do you keep the information flowing so that the business runs, but not let strategically important information out to the wrong hands? And that becomes a very sophisticated balance between information sharing and information security, which is kind of what I've spent my career, at least the last 30 years of my career doing. To be able to share means collaboration and sharing at the right time. People need to know information, but you don't want that information to go beyond them. And you want to make sure that they're only getting what they need and not maybe access to something that you don't want them to access.
Well, in some cases, you might have regulatory obligations to prevent disclosure of sensitive information. One of the things that I've been hearing a lot on the commercial side is this idea of a double firewall. So I'm sure most people have heard about the Great Firewall of China, but what commercial companies are now needing to put in place is a double firewall to make sure that data does not go into China and also Chinese data does not exit China to comply with their respective regulations, both on the United States as well as on the Chinese side. Because it's not just that you're, a commercial entity has to, particularly a globally active commercial entity, usually has to comply with regulations of all of the countries that they're active in. And in some cases, those regulations might conflict with one another.
Right. And that's just going to require more sophistication in how you share and what guardrails you put in between those sharing points and what tracking you do. One of the requirements of the cross-domain stuff was strict auditability, so you can audit everything that ever happens. And sometimes you do one-to-many sharing, right? You come from one source and you'll share it to 13 different sources all at once. So, how you set up your organization to manage that level of sharing is another critical piece.
Well, Ed, I want to say thank you for not only spending your time today, but also serving on Plurilock's board of directors for many years. It's always been a pleasure to work with you.